Hey guys, this is Gabin once again, and today we'll be looking at equation involving indices, right? Equations involving indices, right? So this is very important because it's linked to something very special, something interesting, which is a logarithm. So, but before we get to logarithm, let's see why the idea of logarithm came, right? Because we were in the situation of having to solve equations with indices, right? Involving indices. So how do you do this, right? So this is one of the examples that I selected. Let's look how you could solve this, right? So you have got 3 to the power of x plus 15 equals 177 minus 3 to the power of x. The idea here, or what we are trying to do here, we are trying to solve for x. What's the value of x, right? So in this example, let's use normal algebra skills that we know that we have been doing in the previous videos, and if you haven't watched them, go watch them. So what we have been doing here really is basically what you could do is you have this, so you maybe subtract 15 on both sides. When you do that is you get 3x, right, equal to 177 minus 15, because we are taking 15 away from here, it will become 0, and then 177 minus 15 will give us 162 minus 3 to the power of x. Now we are trying to solve for x, so let's move x on one side, right? Let's force x on left hand side. So we are adding 3 to the power of x on both sides, and when you do that, you have on this left hand side you have x to the power plus 3 to the power of x equals to 162, because here we subtract that value, or x to the power of 3. Now what you have here, remember the idea, this is not 6 to the power of x. No, that's not correct. This is treated the entire thing here is treated as one variable. So right now we have got 2 copies of 3 to the power of x. Now given that we have got 2 copies of 2 to the power of x, what you then do is you have 2, right? You have 2 to the power of 3 to the power of x, which is equal to 162, right? 162. And on my next line, what I'm going to do is I'm going to simplify this. The way I simplify this, divide by 2 on both sides, right? It's normal algebra, divide by 2 on both sides. So when you divide by 2 on both sides, you have 3 to the power of x is equal 162 divided by 2 is 81. Now this is what you have. So you have got 3 to the power of x equals 81, but the idea is to solve for x. What do you do then? What you do then is you could think, the way you would solve it this easy, you could think of this think of this way. What number can we raise to the power of 3 to get 81, right? What number can we raise to the power of 3 to get 81? So that's how you will find the actual base of 3, right? What number can we raise to the power of 80? What number can you raise to the power of 3 to get 81, right? The way you could write that, then the only number that will satisfy that equation is you have 3 to the power of x equals to 3 to the power of 4. Why? Because 3 times 4 times it will give us 81, right? 3 times 3 is 9, 9 times 3 is 27, 27 times 3 will give us 81. Now given that we have got the bases here, the bases are the same here, the bases are the same. If the bases are the same and there is no other expressions in this equation, then we can conclude that therefore x equals 4, right? Therefore x equals 4, and x equals 4 is our solution. So here if you take we could do checking. So the way you check, you have 3 to the power of 4 plus 15 is equal to 177 minus 3 to the power of 4, right? So this is 81 plus 15 is equal to 177 minus 81, right? 81, this is 96, right? And this is equal to this minus that will give us 96, right? 96. And therefore you can see that 96 equals 96. So guys, thank you so much. This is our solution to the answer. So as you have seen it, there's nothing complicated. It's just knowing what to do, knowing how to work out these solutions. And Just make sure you don't make silly mistakes in terms of subtracting or adding. All right, so thank you so much, guys. I will see you in the next video where we look at another example. Thank you.